I have two questions. One question is, in how far were you able to consider in your scenarios the risk of increasingly severe climate impacts on our forests in the next 40 years, looking at the 20-50 years, the risk of more fire, more insects, and so on? And the second question is, so the recommendations make the portfolio make sense to me looking at BC's, the vast majority of BC's ecosystems. I'm glad to hear that you're looking at the different regions. I'm convinced that's very important. I'm glad to see that 250-year-old forest is considered as important. I wonder whether there could be more work done or different approaches to really identify this relatively small subset of forests that is characterized by very high carbon storage per hectare, low disturbance, where we have to expect a very significant initial carbon loss if these types of forests that have been undisturbed in many cases for hundreds of years are being clear-cut, where we don't have a recovery of the carbon storage for many decades. And I was wondering whether it would be meaningful to look at, instead of 250 years, at carbon storage per hectare. These are usually temperate rainforests, like looking at 500 tons per hectare or 1,000 tons per hectare. I'm not sure what would be the best value, but that way maybe it's better, it's even easier to identify this subset of forests, where I think of these similar, like some climate experts refer to unburnable carbon, looking at some forest, looking at some fossil fuel reserves, but I also think there might be some forests out there that should never get logged because we really need them to keep the carbon on the ground. Thanks.
Yeah, thank you. Let me start with the last one. Carolyn and Zach spoke about the what we call a restricted harvest scenario that was actually implemented in response to a request from one of your colleagues. And it's generated a lot of discussion and will clearly generate more work. One of the questions that we have been asked and that we need to revisit in our future analyses is why 250 years? That was clearly a number influenced strongly by coastal thinking, because in the interior, old growth forests considered old growth could be 150 years old or 200 or whatever. So that number is something that we need to revisit and develop more regionally differentiated approaches to that. I like your suggestion about a carbon threshold as an alternative. But there's maybe a different way, yet another way to look at it, and that is sort of the, and I don't have a term for it, but the proportion of the carbon that is in the forest that can actually be utilized. Because if you have a second growth stand, 80 years, 100 years old, much of the carbon that is in virginable timber can actually be utilized in one form or another. Whereas in an old growth forest, you can have a lot of damaged material, rot, wood with interior rot, etc. And so as a consequence, while the value per cubic meter may be higher, the proportion of the carbon that is stored there that can be used can be much smaller. So there are ways in which we think we need to explore this further, different age criteria, carbon stock criteria, or maybe even other things like the index that I just tried to develop in terms of the proportion of wood that can be used, etc. So clearly an area that has a lot of interest. The other point that you made about the regional differentiation, yes, we look at that and have looked at that in the province. There clearly are huge differences in terms of growth rates, decomposition rates, risk to disturbances, etc. across the province, but it's also a fractal problem. As you change your scale, you see similar diversity emerging, right? Even within one of those management units, you have forests that are on the top of a ridge or at the bottom of the ridge. They may experience very, very different susceptibility to climate change, to drought, etc. And so this thinking about every stand has a story. Somebody said yesterday in a stakeholder workshop, really much of forest management is site-specific. And so part of what we need to do is collectively develop the know-how and the ability to think about these decision-making processes in such a way that carbon and other indicators can be taken into consideration. Foresters are already doing this when they do silvicultural prescription, site prescription, etc. What is new is that now, in addition to habitat and many other criteria, they need to also start thinking about carbon in a way that is not normally trained at universities or hasn't been trained when many of us went to universities. And then the first question that you had was that of disturbances. And I think that's a very important aspect. We have not, in this particular analysis, dealt with it yet. It is work that we're planning to do in the remainder of the year, of the project. But we have done earlier work, and there are a number of publications from the team over the years that have highlighted the nature of the stochastic disturbances and the problem that all you can predict for the future for a specific region is a likelihood of disturbances occurring. Whether a disturbance of a wildfire will occur in 2030, 40, or 52, cannot be predicted. But you can develop what are called probability functions of disturbances occurring. And we have done those kinds of analyses. The problem then becomes that you, instead of getting an answer, you get a distribution of answers that depends on the likelihood of certain outcomes. And so what we have not yet done, but need to think about, is how do you combine these probability distributions with different mitigation scenarios? Because now you're looking at two sources of noise. And what Carolyn was describing, when we take a baseline and a mitigation scenario, we would then have to apply these disturbances to both and see what the difference is between the two, and how and if the ranking of alternative changes with this disturbance risk. Carolyn alluded to that briefly when she, in the bar charts, spoke about the uncertainties and the risks of each of the components. If you have a substitution benefit, then that is something that has happened. It's an avoided emission. You can book it and or keep track of it, and it's not reversible. Whereas a carbon storage in a forest, if you have that fire risk that you just described, or insect, or any other form of disturbance like drought that Robbie will speak about, then you have that risk of reversal. And so as we go forward, we not only need to look at what are the strategies, but what are the likelihoods of outcomes, and that is influenced by those disturbance risks. Any other questions?
Mine's not so much a question, Can people hear me?
You need the microphone because you're on the webcast, so others won't hear you if you don't use the microphone.
I just a caution on lumping pulp and paper together. Paper
Yes.
In the province is all made domestically. It uses local energy sources, so it has carbon low levels. Pulp is 100% exported.
Yes.
One of the characteristics that BC fibres, particularly the interior fibres, have because of the climate is it's very easy to refine. And refining is the most intensive part of paper making. So if we produce 2%, 3% less pulp for the world, there will be emissions somewhere else in high carbon generating areas.
Yep.
So, but keeping pulp and paper separate would avoid that. So just a sensitive.
Yeah, that was more sloppy language than anything, and of course, having a lifetime of experience in that sector, you called it. It raises a bigger issue, though, and that's another area where we're contemplating further research, and that's this whole question of leakage, right? So if we make a decision in British Columbia to do something differently, what are the implications of that in other regions of Canada, of North America, of the world? And so we spoke a little bit, about domestic versus global substitution benefits. We only look at the domestic substitution benefits at the moment, but this question of how will the rest of the world respond is something that we have not yet looked at in detail. We make certain assumptions about if you harvest more or less product, then you have corresponding implications in other sectors. And we currently assume that if you harvest less, it means other products may be used, like steel and concrete. But of course, it could be that somewhere else somebody harvests more with the corresponding impacts on greenhouse gas emissions. Now, they will have the same direction of the impact as using steel and concrete, so at least they're not offsetting each other, but that may not always be the case. So this is some area leakage that the response of others is something that needs to be looked at in more detail. But This is really the first time that this kind of work is done. This team's effort over the last 5 years is really the first time that this kind of work is done in Canada, and we're working, of course, with people around the world on these kinds of things. There's, okay, you go first, and because you're closer to the microphone, and then we'll pass it up to you.
We have also questions online.
Okay, yeah, what I thought we do is maybe go till 10:30, so 10 more minutes, and then we'll take a break, maybe a compressed coffee break, and try to catch up with things. Okay, go ahead.
Good morning, great presentations. Thanks for sharing the data. I'm curious, looking at the cost curve and seeing that bioenergy was at the higher end of the range, I'm curious, is that because a lot of slash is just uneconomic to retrieve and utilize? And if that's the case, are you pointing to incentives to utilize that bioenergy or that biomass for bioenergy potential?
Yeah, good catch. So actually the bioenergy is expensive in our analysis because in most cases the bioenergy is replaced for those cheap natural gas energy. And in some remote areas we need to consider those options. And so if you consider those substitution effect plus those transportation from those remote areas to grab those fiber out to the bioenergy facility, it is expensive. And also we need to consider the construction of the bioenergy facility. That's the one-time investment, which is huge, I guess, as well. So yeah, that's, I guess, the main idea of those costly options. Yeah.
Thank you. Oh, sorry.
I'm really excited about some of the options here, but I just was hoping to suggest that we potentially look at going outside the sort of business as usual model in terms of the forest ecosystem management dynamic that's going on in British Columbia right now. For 20 plus years I was involved on a very ground level alternative natural selection forestry model up in the Quesnel area that would blow these numbers right out of the water in terms of employment intensity, low grade natural selection forestry, supplying or creating a value-added silvicultural system that could supply a much longer-term value-added manufacturing sector, building instruments and furniture and all these kinds of things that would lock carbon up in quality products for much longer than anything that's held together with glue. So I would really like to see potentially some of that come within these discussions, looking at really the best case scenario when we break out of business as usual silvicultural, the classic, short rotation fiber mining, and move to something that really could propel those alternative silvicultural systems into something that could really have amazing numbers in terms of this.
Yeah, thank you for making that recommendation. And you heard that Zach, I think it was in the presentation, commented on the fact that these scenarios that we have developed were done with stakeholders involved in the process, but also, of course, the provincial government, industry, and others. And initially, there has been a very conservative approach to these things. We move the dials by small amounts to see what the impact would be. And we are involved in stakeholder consultations. George, we just did one in Nanaimo yesterday. Prince George, Kamloops, and Vancouver are on the list. So in Quesnel, maybe you can scoot over to Prince George. Okay, great. And so I think it is really, really important that the public of British Columbia, we all understand, that we own the forests. 96% of the forests in British Columbia are Crown owned. And I will talk in the last presentation about the next steps, a little bit about developing a vision. And so what I think is really important is that as we think about how can our society go from where we are today to a minus 80% reduction in emissions, we will need to fundamentally rethink how we do certain things. And what you listed, for example, I think is a very viable possible way, community-based forestry, more intensive management. And intensification and enhancement of management doesn't mean, industrial monocultural plantations. We just have to go to Europe and look at, mixed wood forest management, enhancement of productivity. There is so much that we can learn from Sweden, from other Scandinavian countries, from Germany. And I think we just need to create a vision of these kinds of things also being possible in British Columbia. We don't have to do things the way forestry was done here in the 70s and 80s. As we go into this later in the century, there are other opportunities, and they involve greatly enhancing carbon sinks for the benefit of people not only in the rural communities, but also in the urban communities. There was one more question here a moment ago, and then we'll go to a couple of questions online. Who had the question? Yeah, go ahead.
I actually had a question pretty related to the previous one. One of the mitigation strategies that looked pretty promising was higher utilization, both for costs and in the sheer amount it could mitigate. I was wondering if the cost estimate for that is based on current conditions or looking forward. And the reason I'm curious is it seems like the trend right now is to leave less wood in the forest, especially as the good wood becomes less accessible and there's more logging. The amount of waste is pretty astonishing sometimes. So I'm wondering sort of how you guys calculated that based on current conditions or looking forward.
Yeah, the cost of that option was based on the current conditions because you can see that the cost of this high utilization option actually is negative, which means we can gain something from it. But that's based on the assumption that we in order to get the same harvest volume, we reduce the harvest area. So that means we have less cost on the road construction, on the movement of those equipment, that kind of thing. But also there are some other considerations, like we probably need to face the higher cost of the inferior log quality harvest, and the use of those wood will cost a higher unit cost. So that this combination of different considerations of those options for the cost, so that the result you saw is kind of a combination, like the combined effect of the different reduced and increased cost of the current conditions. Yeah, thanks.
So we'll just go to a couple of questions from the webcast.
Okay, so this comes from Gerald Joe. Have you adequately reflected rapid technology advances that will significantly reduce the need for forest products and the amount of excess carbon dioxide in the atmosphere? For example, a company, Global Thermostat, has an industrial-scale process to take CO2 from the atmosphere to make products such as plastic and carbon fiber at the point of manufacture. In particular, this carbon fiber could be used to make buildings, bicycles, cars, etc.
Yeah, so that's a really good question. And I think we all need to understand that as the world is seeking a solution to climate change, we will see technological innovation. We will see opportunities to remove carbon dioxide from the atmosphere and turn it either into a liquid that is pumped underground or into a product. There's some really exciting ideas around taking carbon fibers and making rods that are equivalent to reinforced steel that can then be inserted into concrete. A lot of these processes are, of course, very energy intensive, and I am hugely supportive of all efforts to try to reduce carbon dioxide in the atmosphere. Every analysis that I've seen to date indicates that the scale at which this can be done is relatively small at the moment. The costs per ton are very high. And why would we go through an elaborate process of trying to reconstruct something that can hold strength or avoid compression when we have wood to achieve the very same outcome already? Often at per pound, wood is stronger than steel. And so we have materials that are renewably constructed with low energy that can serve these purposes. That doesn't mean we shouldn't try the other things. We absolutely have to. Anything that we can do to remove carbon dioxide of the atmosphere, but the scale at which this can be done globally and the scale at the cost per ton is at the moment not such that we will
Okay.
solve the problem with it. And then you had a second question?
Yes, there is a second question. This is coming from UMBC. We have a satellite room over there. So were you able to, at all, to consider market demand in LLPs? Is it realistic to assume that we could sell 4% more panels in your example?
Yeah, so I think there are two things that work together. Market demand is partly the result of consumer awareness and willingness to recognize the environmental benefits of using wood over more emissions-intensive materials. But it's also aided by technological advances and building codes. So governments can play a role here. British Columbia, Gordon Campbell in 2008 introduced a wood-first policy for publicly funded buildings. The building code change that has already occurred to 8-story buildings. And there are other efforts underway. There are already movements towards the national building code to 12 stories. And in fact, in the United States, they're speaking of 21-story wooden buildings as part of the building code in the coming years. So this is not happening overnight. But what is happening is a growing awareness of the ability to construct with wood in a way that was not conceivable even a few years ago. And so I think the demand for these products is easily created. I don't see that as a problem at all, as long as the regulations are in place, it's cost effective, and it's, from an engineering perspective, a sound solution. People certainly like living in wooden buildings more than in a concrete building.
Yeah, I think just building on that, what we're trying to encourage is a longer life in the wood product. So if we can make a structural product out of smaller pieces of wood that can displace steel and concrete, if we can use the existing lumber that's now being used and create CLT and make 18-story buildings, that's the best option. Yeah. And then cascaded wood use after that. So after you're done with whatever it is, 75 years from now, you can no longer use it in the building, then make something else out of it, or use it for energy and displacing fossil fuel. So always have the next use in mind whenever you're creating something. Yeah. And certainly make good, long-lasting wood products whenever you can.
So thanks for the excellent questions. I'd like to take a quick break.